Okay, so the arithmetic mean of two numbers A and B is the sum of A and B divided by 2, so it's their average, where A, that average, and B constitute a countable arithmetic sequence with a common difference of D equals that average of B minus A over 2. I know that sounds really, really confusing. Of course, we're going to do some examples where it's going to make more sense. Now we're going to go ahead and look at a sequence, A, C1, C2, all the way to CK, and then B, where the C values, C1, C2, all the way to CK, represent arithmetic means between A and B.
You just chose that spot.
That is true.
I could see it, and then she.
I did move it.
Yeah, that just
Oh, okay.
I was like,
Anything no back of that makes it worse.
So I know, again, this sounds really, really confusing. It just means if I have two terms in a sequence, I can insert terms between it that are equal distance from each other and from endpoints A and B.
Wait, so the number's always gonna be like whole numbers?
No.
yeah.
So we're going to go ahead and start an example of this that I think will make a lot more sense. In the example, we are going to insert 3 arithmetic means between two term values. So the first thing we're going to do when we are presented with a problem like this is we need to see if we can figure out our common difference D, because it is going to vary with each sequence that we have based off of the terms that we are given. So if I were to write this sequence out, my first term would be 2. I'm inserting 3 arithmetic means between 2 and 9. So I'm going to have C1, C2, and C3, and then my sequence will end at 9. We do not have to indicate that this goes on infinitely because I mentioned before that this is a finite or countable sequence, which means it terminates. If this is my sequence, then A1 is 2, and my 5th term is 9, which means I'm technically finding terms 2, 3, and 4, which means that this is just an arithmetic sequence that I can use all of the things I learned yesterday with. So working backwards, I'm actually going to use our nth term formula to solve for my common difference D. Which term do you think I'm going to use to establish that nth term formula? Am I going to use the first term or the 5th term? The 5th term, because it uses the first term in the formula. So I'm using my 5th term formula, which tells me I have my first term A1 plus 5 minus 1 times my common difference D. I go ahead and fill in the information that I have. So I know that my 5th term is 9. I know that my first term is 2. And 5 minus 1 makes 4. So the equation I have is 9 equals 2 plus 4D. And now I just need to solve for D. So I'm going to subtract 2 over to get 7 equals 4D. And then I'm going to divide by 4. So my common difference is equal to 7 over 4 for this finite sequence. Are we all okay so far? I know that each of the arithmetic means that I'm putting in is equal distance from each of the terms that I was given. So that means C1 is going to be this difference away from my first term. C2 is going to be this difference away from C1. C3 is going to be this distance away from C2. And then it's also going to be that distance away from A5, which is 9. So to find C1, C2, and C3, I'm just going to continually add my common difference D. So to formally write that out, C1 equals my first term plus that common difference. I know that the first term was 2. Of course, I can't add a whole number and a fraction together, so I need to re-represent 2 as a fraction with a denominator of 4. So what fraction is 2 equal to with a denominator of 4? 8 over 4. We just multiply the top and bottom by 4 over 4, and I get 8 over 4 plus 7 over 4 equals 15 over 4, and that is the first arithmetic mean that I'm inputting here. Then to find C2, I take C1 and I add my common difference to it. I know C1 is 15 over 4. And I add my common difference of 7 over 4 to it. I get what? 22 over 4, which we can absolutely reduce into 11 over 2, and we should definitely reduce if possible. And then I do the same thing for C3. C3 is going to equal C2 plus my common difference of 7 over 4. I'm going to use the 22 over 4 version of C2 because it has the denominator that I want. I'm going to add 7 over 4 to it to get C3, which is 29 over 4. So now I have gone ahead and I have identified the 3 arithmetic means that I had to input between term 1 and term 5. And then, of course, I will write it out as that finite sequence that starts at 2 and ends at 9.
How is that any different than what we did?
Yesterday we were given terms. Today we have missing terms that we just had to work backwards to fill in. It's the same concept. They just call it something else. Yeah, same concept. So my finite sequence started at 2. My first arithmetic mean was 15 over 4. Then I had 11 over 2. Then I had 29 over 4. And I ended at 9.
So you want those fractions, not decimals?
Yes, absolutely fractions. Because sometimes we're going to get a decimal that doesn't terminate.
I remember that message.
On the homework, yeah, I did ask. There are, I think, 2 problems that I gave you arithmetic mean were on the homework. Yes.
No, wait.
I know I gave you some problems on the homework that deal with this. Okay, questions, concerns, or issues so far?
Well, I remember getting one like a decimal.
You should never use a decimal.
I didn't know the fraction. It was like 2.211. You can set your calculator to solve for a fraction.
Yeah. I can show you later. If it makes you feel better, we just did all of this on my notes. So we're almost done.
Page or like the page
Like-
to the paragraph.
This. This. Okay, so we're going to go ahead and do another example, and then we're going to do the last little piece, which is extremely easy. So this one is actually a word problem. I know we're super excited about that. And I know I gave you one like this on the homework. No, not mine. Took 7 lines. So this example says that a carpenter wishes to construct a ladder with 9 rungs whose lengths decrease uniformly from 24 inches at the base to 18 inches at the top. It would ask us to identify the lengths of the 7 intermediate rungs, so the rungs in between the base and the top. It is the same concept as the one that we just did. So the first thing we're going to do is we're going to write out the sequence that it's asking us for, and then we're going to find those missing rung values. I will give you guys a second to finish writing before we get started. I will tell you that even though in the previous problem I said no fractions, when we're talking about length, I said no decimals. When we're talking about length, a decimal is acceptable. Because when we are measuring something, we don't measure it as, 15 and 3/18. We measure it as 15 point whatever the decimal is. So when we are talking about length, a decimal is acceptable. So what is the sequence I'm actually trying to find here? What's the base length of my rung? Or what's the length of my base rung?
24.
24. Do I know the next rung? No, in fact, I don't know the next 7, so that's going to be C1 through C7. And then I know that my top rung is 18 inches. So this is the sequence that I'm solving for. I know the first term, and I know the 9th term, but I need to find the 7 in between. So just like on the previous problem, I'm going to set up an nth term formula for this particular sequence and a term in the sequence. To do this, which term am I going to use? 18. I'm going to use the last one, which is A9, if you wanted to number them that way. I can't use A1 because I have to use the term A1 in my nth term formula. So that means I'm going to have A9 equals my first term plus 9 minus 1 times my common difference D. Plug in the values that I have, which is 18 equals 24 plus 8 times D. Go ahead and do the subtraction. 18 minus 24 is -6. I divide by 8, and I get D equals -0.75. Or -3/4, depending on how you chose to write it. Again, this is length, so it is perfectly acceptable for me to use a decimal. What does this D equals -0.75 tell me about this problem? What's decreasing? The length of my rungs are decreasing as I go up to the top by a length of -0.75 inches. Or decreasing 5.75 inches, depending how you want to word it. So that means as I go up, my rungs are actually getting shorter and shorter and shorter at this constant rate of change. So then how am I going to find my first intermediate rung there? So C1. Take 24 and subtract from it the negative, or subtract from it 0.75, and that's going to give me my first intermediate rung. So C1 here, if you want to formally write it out, is A1 plus D, where A1 is 24, and my D is -0.75. When I subtract it, I get 23.25 as my first rung length. And then I just keep working down until all 7 of my intermediate rungs have a length that is my respective sequence value. So work through those now, please. All 7 of them. as you work through it, you should end up with these 9 rough lengths, ranging from 24 at the bottom to 18 at the top. Please check your work with what I have up here, and if you're good, then you're done. Is anybody running into any major issues with this? No, right? It's pretty easy. Once we figure out the common difference, we just add or subtract it for the appropriate number of arithmetic means or terms that I want to insert into the sequence, and then I'm finished. How do we feel about arithmetic means in general? Decent? Okay, so I do believe there's 1 or 2 questions on your homework where I asked you something related to arithmetic means and what you had to find for a given sequence. If you run into issues on that, of course, let me know. If not, we're going to move on to the last little portion here. Then we are finished. I'll give you guys a second to finish writing because I see some people still writing. Okay, so the last example that we're going to do is actually different than arithmetic mean. It is given a series, which is the sum of sequence values. Write the summation notation for that particular sum. So this one asks us to express the addition of 1/4, 2 ninths, 3/14, 4 19ths, 5 24ths, and 6 29ths in terms of summation notation, which is that funky looking E. So just to remind you, when I talk about summation notation, I talk about the funky little E that says we are adding from term 1 to n of a sequence that follows the rule A of n. So in order to write it in this notation, there are a few pieces of information that I need to find so that I can fill it in here. What is one piece of information that I need to find to fill into the summation notation? No, K is unchanging, it just is the term that we're starting with.
Like your n.
Okay, so n is going to be the number of terms that I'm adding together. That's really easy because I can just count how many there are right here. So how many terms am I adding together? 6. So I can fill that part in. So now I know that I'm adding from term 1 to term 6. What other piece of information do I need to find to fill into this?
Your a.
My A of n. So that is the explicit rule that my sequence follows. There's something very unique about an explicit rule for a fractional sequence, and that is that it technically has 2 that we then put together to create 1. So what I'm going to have to do is I'm going to have to find the nth term rule for my numerator and the nth term rule for my denominator, and then put those together to create my nth term rule for the entire sequence.
Is that like what we're solving for? Like it's just to fill in this E.
Yeah, we're just filling in the E. Yeah, that's it. So we're going to start with the numerator, which means all of the tops of my fraction. If I'm looking at those independently, it's just 1, 2, 3, 4, 5, and 6, right? Which means A of n here is equal to, what's my first term in that numerator sequence? 1 plus n minus 1 times, what's my common difference in that numerator? 1, because from term 1 to term 2, I added 1. From term 2 to term 3, I added 1. From 3 to 4, I added 1. So that means that my common difference is also 1, which allows me to simplify that into something really, really easy to work with. When I simplify it, I get 1 plus n minus 1, which simplifies into 1. Just n. So my nth term rule, for that numerator is just a of n equals n. That was really, really easy. But now I get to do the same thing with my denominator. Afraid it would do that. So now we're looking at the bottoms of all of my fractions. This one won't be quite as easy, but it's still very similar in the process. I'm going to start my nth term rule. What's my first term in that denominator sequence? 4. Plus n minus 1 times my common difference. So what's my common difference from term to term in that denominator sequence? 5. From 4 to 9, I added 5. From 9 to 14, I added 5. From 14 to 19, I added 5. So it has a common difference of 5. And then I just simplify it out like I did my previous term to see what it comes out to be. And when I do, I get 5n minus 1. Are we all okay with that? So when you're given a fractional sum or sequence, we treat the numerator and denominator independently. And then I will put these nth term rules together to create the overall nth term rule for my entire sequence. So that's the last little piece I need to fill in here. So my summation goes from 1 to 6 of my numerator rule over my denominator rule. And that's all I needed here. So this is equivalent to the summation from 1 to 6 of n over 5n minus 1. And then we are finished with the entire set of notes. So you should definitely be able to finish your homework now, and tomorrow we will start with geometric sequences.
That was second.